All right, welcome everyone. Today we're going to be talking about CRUD with Django. The end state of today will be that by the end of this lecture, we will have a functioning Django API that enforces RESTful API conventions and allows for CRUD capabilities. The highlights for this lecture will be HTTP methods for CRUD actions, how they correspond to one another, corresponding HTTP actions to the appropriate API endpoints, and then leveraging Django REST Framework API views, and model serializers to generate appropriate API behavior. So it's just going to be so far we've concentrated in all of the reading portion of our API, and today we're going to dive into, hey, how do we create information? How do we update information or delete information from our database? In part one, we'll talk about what is CRUD, CRUD HTTP designators, why request.data. And this request.data portion is going to be kind of like a deep dive into the difference between URL patterns and passing information between URL parameters and utilizing the body of a request. And then we have creating an update, which is going to be our put method for a Pokemon view, refactoring repeated logic to make sure that we're following principles like the dry principle. Don't repeat yourself. And then we'll go into testing the put method for our API view. All right. At this point, does anyone have any questions over the material that we'll be covering today? Perfect. If no one has any questions, then the first things we're going to talk about is going to be our HTTP operators. So currently right now, we have the ability to have a client that would be able to send a GET request to grab specific information. That information would go to our backend. Our backend would then process it to the appropriate app, which that app will route through its app URLs to the appropriate API view. That API view may be a model view controller, or it may just be an API view that doesn't actually communicate with the database. All right. From there, if it is a model view controller, it'll talk to our model serializers, which then communicate with the model. That sends a query to our database, returns information back to our model as a query set, which gets serialized by our model serializer, then gets fed as a response to our API view. That response gets sent to the client. And currently all we have here is an axios.get, which is going to be our read method. Well, today we're going to talk about different HTTP methods that are available to us. So I'm just going to quickly write this table here. And I'm going to go ahead and divide this into separate columns. We may need one other one here. So let me go ahead and copy and paste that really quick. All right. Now on this left-hand side, I'm going to put all of the different actions that are available within a Django API. And in this right-hand side, I'll place the HTTP method that corresponds to said action. Now, all of this is kind of something called RESTful API conventions. We know that what we're creating is a RESTful API, but what exactly are these conventions that we keep mentioning? Well, these conventions were generated by pretty much the entire development industry. There's no sort of code reinforcement as to, hey, you can't conduct a specific action on this HTTP method because that doesn't follow RESTful API convention. There's nothing in your VS Code, nothing inside of your code editors, or nothing within the actions where your code is being compiled that's going to prevent you to mix these things around. But as a developing community where all of the developers kind of just continue to develop different APIs and interacting with APIs, there's kind of like a status quo for everybody, right? Everyone knows, hey, specific things like, for example, if I want to read data, I would have to send a GET request. And if you notice, with all of the APIs that we've interacted so far, we've always been sending GET requests, whether it's through axios.get when we're working within JavaScript, or through requests.get when we're working with server-side APIs with Python, right? Again, this isn't enforced by anything within your code. It's just kind of the status quo, what everybody had agreed to. And let me give this a little bit of headers. There you go. All right. So we know that to be able to read data, we have to send GET request. But CRUD stands for create, read, which we see up above. We have update and delete. Well, one of these that isn't very hard to match is going to be the delete method. We know that we have the ability to send delete requests. And anytime I want to delete data from my database, it only makes sense that I would send a delete request. But what about create and update? We've talked about the different HTTP methods before. Can anyone tell me what two methods are still left over? Go ahead, Tony.
Put request.
All right, so we have the put request. What else do we have?
Post.
Perfect. And we have the post request, right? Now, a put request and a post request, as they're being sent, a post request, it only makes, when I think about it, I think, hey, I'm posting something into the database. I'm not putting information, I am posting information into the database. So because I am posting information, I would call this the create method, right? That's how I would match it. Anytime I want to create something or an instance of my model or an entry into my data table, I would send a post request. And with update, anytime I want to update an existing entry in my data table, I would send a put request. All right. So there's a kind of the bigger aspect there as to how HTTP methods are matched. But now let's talk about URL patterns as well, right? Because that seems kind of important. We should know what kind of URL endpoints it should match with. And we'll dive into these as we go through. But for example, when we're going to get an action, if we want to get all, then we would send it to the pluralized view. Right? So Pokemon, which would be for all. And if we wanted one, we would send it to the Pokemon slash ID view, which would be for an instance. And let me actually just stretch these out a little bit. All right. Well, what about when I want to create something? I want to post an entry into a data table. Which of these two endpoints does it make sense to send that request to? Go for Alex.
The instance?
An instance. Okay. Well, if I send it to an instance, right? Notice that one of my parameters is integer ID. So there would already have to exist something inside of my data table in order for me to send a post request, right?
Mhm.
So instead, we would actually send this to the Pokemon, which is for all,
Damn.
right? It doesn't exist just yet, but we're going to create an existence of it within this pluralized view. Now, what about update? If we want to update an entry that already exists within my data table, which URL pattern would we send that request to? In this case, we would actually send it to the instance because now we are updating something that already exists within my database, right? You could write an update method to the all, and that's if you're trying to do like a massive update where every single entry gets updated at once. But that's just kind of very specific to your API design and not very common, right? We wouldn't want to have something like a massive update that goes through everything unless your API is specifically designed to handle something like that. And same thing with delete, right? So delete, we would want to send a delete request to delete one entry. So we would send it to the instance. And unless you wanted to, for whatever reason, have something like a massive deletion where every single thing inside of the data table gets deleted. But again, not very common unless your API specifically dictates a need for that. All right, so there's our RESTful API conventions. We have our actions attached to specific HTTP methods and actually attached to specific URL patterns as well, where one of them access a pluralized version of the endpoint, and the other accesses the instance version of the endpoint. Does anyone have any questions about that? All right, awesome. Let me go ahead and actually grab this here and send it to all of us. Oh, and there you go. And I'm going to send this inside of the Buffalo channel. That way it's available to everybody. I'll also make sure that it gets included inside of demos and notes. All right. So now we understand a little bit about RESTful API, how to send data to one another. And in today's lecture, the first thing that we're going to dive into is going to be this put method. So I want to actually start working to be able to update information inside of my API view. So following this convention here, I would come over to my project. So here's my Poke API project. I know that I'm going to be working within the Pokemon app, and I could take a look at the URL patterns. Well, in the URL patterns, we can see here that I have a Pokemon, right? And that's the URL pattern that I wanted to ping. If I look here, I can see that it's Pokemon slash integer ID. Everything inside of this URL patterns is prepended by this Pokemon slash. So the view that I want to work with is going to be the a Pokemon view. So I could open that up. And I know that this is where I want to add my request. All right, let's go ahead and make sure that everything already works here. I'm going to do Python, Poke API, manage py, run server to make sure all of this is executable. All right, so my server is running. I'm going to open that up in Django. And I already have it open here where I could grab all the instance of one Pokemon. So here we can have Pikachu captured, and Pikachu is an electric type. Fantastic. So I have everything that I need to know about Pikachu already serialized, and everything is working. If I go to grab all, I can see all of my different entries of a Pokemon are still available. All right. So my API works. My Django server is up and running. I can actually start working in creating this put method, right? Because as we saw in our data table here, what we're working with is an HTTP put, right? So I'm receiving a put request to be able to update this Pokemon. All right, so what is the goal of the put request? The goal of the put request is to grab the selected Pokemon, grab the incoming data utilized to update the Pokemon. We then want to update the Pokemon entry through our model serializer. save it, and return a response to the user. That response could either be successful or it could catch errors. So there's the mission of our put request. Let's start writing that in code. Here we have our put method, which takes in self, request, because we will always have request, the ID. And now we can actually start writing information. We have the selected Pokemon, which will be Pokemon.objects.get, where ID is equal to ID. And this is going to grab from the database where select all from Pokemon, where primary key is equal to ID. All right, a little bit of a refresher. We've already seen this. Well, now how do I grab the data from this response? And for now, I'm just going to return response. And let's do working on update. All right, we're saying we're going to grab incoming data to update this Pokemon. Well, let's take a look at the different parameters of a Pokemon. A Pokemon has moves, it has an ID, it has a name, level, date encountered, captured Pokemon, etc. All right, what if I wanted to update level, date encountered, captured Pokemon, description, and captured? One, two, three, four, five. All five of those different parameters. How could I do that? As of now, how do we know that we can send information through an API? Let's hear it, Alex.
Hmm. We could use excludes with the serializer.
I see.
Yes.
To be able to exclude ID, moves, and name.
Yes.
Okay, awesome. Yeah, you're not wrong. The question that I'm asking is how could a user be able to send us new data for level, date encountered, captured, description, and captured Pokemon?
My bad. I'm on like 3 hours of sleep.
No, no problem at all. All right. Well, so far, we know that we can send everything through URL parameters, right? So technically, we could design our API to take in something like, hey, description would be something like such, and then the user could provide description. We could do something where captured, and then somebody can provide a Boolean variable for captured, which is true or false, and so on. But imagine doing that for every single one of these fields, right? Our URL pattern would just be a massive thing that may occupy the entire URL line. And it just doesn't follow RESTful API conventions. Like this doesn't look dynamic at all because now we're also going to have a bunch of if and else statements trying to check each one of these keyboard arguments to see if they're present. And if they are, then we can update our Pokemon. But if they're not, we would have to redesign our API to kind of account for missing values and changing the order as to how information is coming in, right? It would throw a bunch of errors. So instead of sharing information this way, what we have is something called data, which is also known as the body of the request. Just like a response has a body, we've seen this with the Poke API, right? When we wanted to grab data out of a response, we usually have to do, hey, we have async and await, the response comes back, and then if we look at the response.data, that gives us the body of the response. Currently, right now, what we have here is the body of the response. Well, just like a response has a body, so does a request. For example, if I print request.data and I send this again, you can see that everything goes through. It's now allowing me for my content here, which we'll go into here shortly. But now if we come down below, Oh, where's my print request data? Oh, I didn't receive the put request. I apologize. Let me send that. Well, request.data comes as an empty object. It's not recognizing anything in there. Well, we could start filling it in down here. We have application JSON, and we could actually add some JSON content. Now, you could do everything through Django REST frameworks. And I understand why people would want to utilize this and just stay within Django REST frameworks. But it is important for us here in Code Platoon that you also pick up an extra framework, such as Postman. So now let's practice this through Postman, right? I can go to /1, send my GET request. So here's my GET request response coming back. Here we can dive into, I want to send a put request. And when I send a put request, you can see I'm working on update. And if we take a look at this object, we still have an empty object, all right? Well, here in Postman, we also have the ability to send a body within our request. We can open up the body tab. Here, I want to make sure that this is selected as raw. And I'm also going to select my raw input as JSON. Notice that it gives you JavaScript available as well. For just general purposes, keep it with JSON, right? So what we're sending is a raw JSON string. And in a JSON string, we usually want a JSON object to start us off. So here we can say something like sender, and we can say the sender is Postman that is sending the request. Well, now when I send the request, I still will get working on an update. And if I take a look at my server, request.data is now showing me sender is Postman. Right? Everything I am typing into request.data is being processed within the request itself. Right? So the body of my request can be grabbed by my server. Well, now that I have request.data available to me, I can grab the different portions of my Pokemon model and update them. So what we discussed here was that we would update something like level. We would update something like, let's do captured and description. Why not? Okay, so here we're going to have level. We have captured, which is a Boolean variable. And let's do level 1. Captured a Boolean variable, let's do false. And this is JSON, so it should be with a lowercase. And then finally, description. Pikachu is a yellow animal that uses electricity. All right. So now here's my data, the body of my request. If I send this, nothing has changed. I can come back over. And now within my view, I can see my entire dictionary object is still there, right? Now it's a dictionary inside of Python. We have level, captured, description, and Pikachu. If I take a look at my original data, so if I change this to a GET request and I send this information, well, we can see that the level is 20. The description hasn't changed, and we still have captured true. Okay, fantastic. Let's go ahead and change this information with the data coming back from the request. Well, first of all, we want to actually establish the data. And request.data is a dictionary. I don't want to mutate the original data value. So instead, I'm going to create a copy of it. All right. So there I have my copy of request.data. I have my selected Pokemon, and I just grab the data that's being sent through the user. Well, now I can go into the process of updating the Pokemon to my model serializer, saving it, and sending a response to my user. And I see a hand up. Go ahead, Wally.
Yeah. So would you ever need to do a deep copy in case of your data is recursive or like nested?
That's not going to be typical. That's
Hmm.
very situational dependent. And I think that if you have a specific endpoint that would require that, then you would want to do that.
Hmm.
But again, very situation dependent and not common.
Okay.
Does that answer your question?
Yeah.
All right. Okay, so now we have our selected Pokemon. We have the data coming in through the user. So this is capturing the data within the request body. And now we can actually update it with our Pokemon serializer. So we can say serialized Pokemon is equal to my Pokemon serializer. The object that I want to update will be the selected Pokemon. The data that I want to update it with will be the data that came in from the request. And this is going to be partial. So I'll pass in partial equals true to ensure that this is all partial. All right. Now that we have that partial update, because we're not passing in all fields, we're only passing in some of the fields, I'll say if serialized Pokemon is valid, then I'll save my Pokemon and I'll return a response of serialized Pokemon dot data. And here we could decide within how we want to do our HTTP status. For now, I'll just keep it with, and let me go ahead and do this number. Oh, I apologize. There you go. Sorry about that, everyone. For now, I'll just keep it with HTTP 200, okay. So currently my status will come back with HTTP 200, okay. If this is not successful, so else, I can return a response with serialized Pokemon dot errors. And here I would return a status that would let the user know that they did something wrong. Well, in this case, the status that we're working with would be HTTP 400 bad request. This is 400 letting the user know this is your fault. The request that you are sending is invalid. Okay, so we'll come down. And here we'll do HTTP 400 bad request. Okay, so let's go through this again. We receive the request. We grab a Pokemon from the database, which in this case, the selected Pokemon will be selected through its ID. We then grab the data within the body of the request. We pass it into our serialized Pokemon, or we pass in the selected Pokemon, the data that we want to conduct an update with, and establish that this is a partial update, meaning that not all fields will be present. If the serialized Pokemon is valid, we'll save the Pokemon and return that data, letting them know that the request was successful. Otherwise, we're going to send them their errors as to why our serializer didn't work. And we'll also establish, hey, this is a bad request. Let's go ahead and go through this process. Gonna come back over. Notice that sender is not something that's going to match with any of our fields. That's okay because we have a partial. So that partial argument is only going to look for matching fields and execute them. And it'll disregard this sender key pair value. All right, I'm going to select my put request. I'll send my request. And now Pikachu has different values. Pikachu is now level 1, whereas before it was level 20. Its captured status is now false, where before it was true. And its description has changed to Pikachu is a yellow animal that uses electricity, where before it would use an electric stone to be able to evolve into Raichu. Right, so this is a successful request. And notice that we still have 200 okay. Now what happens if I mess this up? Let's say that I turn this into a string, and I also turn this into a string. All right, now I'm passing in string parameters for level and captured. Let's see what happens when I send this request. Well, when I send this request, it looks like it was still successful. So I'm wondering if my serializer is able to actually typecast this information. So let me change it here. Let's do 123. Let's do 20. And now send our put request. This should create an error. All right. So now I actually get my error. It's telling me, hey, we're getting a 400 bad request. This is your fault. The server couldn't understand the request, maybe a bad syntax. All right. The level here is a valid integer is required, and captured is must be a valid Boolean. So this tells the user what their errors were when sending the request. All right. So 400 bad requests. This is your fault. Does anyone have any questions about the put method? Let's hear it, Sam.
I just have a question about the partial equals true. So would that still be able to handle a put request that changes all fields just because it's looking for just whatever is valid?
It would, yes. So it would still be able to handle a put request that has all fields in there. This just kind of gives us the capability to send a request with data where some fields are missing. All right. Any other questions? Okay, awesome. Since there aren't any other questions, I also want to make sure we tie in the dots and see what this looks like in JavaScript. We're so used to working with Axios now after interacting with our entire React project that it may be a good idea for us to also see, hey, how does this work when I'm working within React? Notice that I have two terminals running. One of them is running my API project. In this case, I have a client that I've created that has a main.js script. You don't have this available to you, and we're not going to go through the process of installing all of this since this is purely additional material and it's not part of our curriculum. Now, here in client, you can see that we're utilizing Axios inside of this main.js script. We have a make request function, which is going to take in an endpoint. Here's my API v1, which is going to be my Django API base URL. And then all we're going to do is we're going to attach the endpoint to it. From there, we'll log into the console response.data. Here I have endpoint, which is going to be what I mutate, and then my make request. All right. I'm going to change directory into client. And here I'm going to run node main.js. As of right now, this should grab me a list of all my Pokemon. All right, let's see what we have here. So it looks like we have some sort of error here. So cannot find APN modules. Oh, should probably run npm install. There you go. All right. So now my request is being executed. Here I have a list of objects where I have Blastoise, Eevee, Charizard, Pikachu. All four of my Pokemon are available to me. If this was a React application, this would be a simple use effect where we're sending information to grab all the Pokemon and display them to the user, right? We would then map through the response, which would store in some sort of use state and be able to display Pokemon cards to the user. It should look very familiar. Does anyone have any questions about this up to this point? Okay, well, let's send it specifically, right? I want to send where I have my parameter of one. I execute node main.js. And now we can see that only Pikachu is coming in. Well, if I want to change this, I just want to send a put request that would change the captured value to false. Well, here I would specify what I'm sending is a put request. And here I would add a data component that would specify the data that I want to send. So here I can say data is captured is now true. All right, so there's my request. I'm sending a data parameter within my request. This is going to be grabbed by Django, run through my API serializer or through my model serializer of partial equals true for the selected Pokemon. And then we'll see the response here shortly. So I run Node.js. We can see that before captured was false, and now captured is true. So my request was successful. The ID of 1 was for Pikachu. I was able to change it to captured equals true. And I can even update the level again back to 20. So we can do level is 20. And if I send my request one more time, we can see that level has now been updated from 1, which is what it was before, to 20. So that's kind of tying in the dots to our client, right? We're utilizing Axios within some sort of React application or front-end application to be able to make requests. And all of the data that we want to update our Pokemon with will be sent within the data parameter. All right. At this point, does anyone have any questions over how we created a put method to be able to update our Pikachu within our database? Doesn't seem like we have any questions. Last but not least, let's dive into testing this information. Right, I'm going to close this down. I'm going to come back over to my views. My views is what I want to be tested. I'm going to open up this test directory, and here I have this test views. So let's make sure this test views still work. I'm assuming one of these is going to break because we've done a couple of changes to our API views. So let's do, oh, let me actually change here. And Control C. Let's do Python, manage PY, test, tests. And what I want to test is my test views. This is going to take dot notation, so I'm actually going to take this all off and change this to dot notation. Okay, so far it seems like everything worked correctly. We have a 200 okay. Awesome. Well, now let's start working with CRUD. So for our CRUD capabilities, here I'm going to do the test. This is going to be my third test. And it's going to be for updating a Pokemon. This will take itself. Same thing as before. I'm going to create a client is equal to self.client, or excuse me, to client. This is going to send a request and have a response. So here we're going to have client dot reverse, excuse me, client dot put to the reverse value of a URL pattern. In this case, the URL pattern will change. We'll change it here shortly. This will also have some arguments that we'll be sending. And this put request will also have a data component that we'll dive into here shortly. Now from there, we want to make sure that the response is successful. So first I'll grab data is equal to response.data. I'll say with self.subtest. I want to ensure. So I'll say self.assert equal that response dot status is of 200 because it's going to be successful. And then I just want to make sure that the data matches. Right. So I'll say if, let me make sure that my fixture data is up to date here. So here I have my Pokemon test fixture. And go to my Pokemon app. Here's my test fixture. So Pikachu is currently captured is true. So I'm just going to change that to false and make sure that that works. All right. So now I can do self dot assert true. And this is going to be not data dot captured because we're going to be changing it to false. All right. Let's see. So this reverse method is going to be asking for a URL pattern, right? Let's come back over to our Pokemon URLs. Here we named it a Pokemon. So this is going to be the pattern that we're going to be sending it to. So I can come back over to my test view and specify that. The arguments here will be where the ID is of 1. So I could just pass in the argument. And then the data component. Go ahead and break these up a little bit. Now my data component may look a little bit different here. All right. Here we're going to have captured. And we're going to send this capture to false. Oh. Now, we also want to dictate to Django what kind of request we're going to be sending. And let's actually execute this test as of now so that we can see the errors that we may get. So here I'm going to send it to test views, and I get an error here. So I'm getting a 415 error code, which is who knows where that's coming from. So it's telling me self.assert equals status code is equal to 200. And we're also getting a test03 got an error. We're getting failure and an error from this third test. So here we see test03, not data.captured. So dictionary object has no attribute name captured. So I received some sort of dictionary object. And then we dive into it. And here we have our second failure where it's telling me, hey, this isn't right. Like the assertion that you're looking for doesn't exist. So there's something going on here. Let's go ahead and actually print response.data. I send my request one more time. When I print the data that comes in, here I get detail. So unsupported media type, application octet stream in request. And it tells me this is an unsupported media type. Well, that's because by default, Django is actually sending itself something called octet string. I need to specify that the content type that I will be sending will be of application/JSON. And now, when I execute my request, it looks like I still got an error here, but now my request is actually working. So here's the data that came back. All right. And I'm getting an error. So a return date object has no attribute name captured. All right, let's make sure that's true. I do see a captured attribute there. So there's something else going on. Let's see here. So I have print. See what happens if I do print captured. Okay, so that is coming back as false. So maybe it's the way I'm accessing it. Let me go ahead and grab that here. All right. And now it's able to do my request. Fantastic. So I'm currently updating my Pokemon. I generated a client. Here's my response. I grab the data. I make sure that it's a successful request. And I ensure that that data was actually changed from true to false. Does anyone have any questions about how we created this test for updating a Pokemon? Okay, great. Since no one has any questions, let's go back to our view and clean it up a little bit now. In our view, we have a little bit of repeated code. For example, we have our selected Pokemon being repeated twice. And we don't necessarily want this repetitive process to continue. So instead, I'm going to create a method called getPokemon that will take in self and an ID. This ID will be of an integer type, and this will return a Pokemon object. All right. Now, again, we're going to grab a Pokemon, but we're going to do it in a different way. I'll say selected Pokemon is equal to Pokemon dot objects dot get, where ID is equal to ID. And then I'll return the selected Pokemon. Now this works great. But what happens if this Pokemon is not in the database? Let's go ahead and try it out. Let's do Python manage py run server. Let's run something with the ID of 15 and send a GET request. Well, this actually raises an error that doesn't even return in JSON. So this is pretty bad, right? We're getting Pokemon matching query does not exist. And we're getting a 500 internal server error, which isn't right. We should be receiving a 404 not found, right? Because there's nothing matching the query. So we could write an entire block of code here to be able to handle this. Hey, if the Pokemon is present, then do this. And if not, return the following. But since Django is batteries included, it actually comes with something called get object or 404. So we're going to change this get a Pokemon to run. And let me actually just copy and paste it. That way we could just copy, comment it out, and we can see the difference. We're going to get object or 404, where we're passing in Pokemon as the model that we're working with, where ID is equal to ID. All right, so this is the same exact thing as above, but now if the Pokemon isn't present, it'll automatically return a 404. So now let's change some of the logic here. Here, we would change this to, hey, I want to utilize self.getPokemon, where I'm passing in the ID. And I would do that down below as well, where I have self.getPokemon. And I'm passing in the ID. So now Django does its updates. Let's see what happens to our request now when we run this same ID value. Well, now we're getting a 404 error telling me, hey, this Pokemon doesn't exist within the database. I don't know what it is that you're looking for. And I'm even getting a JSON object that tells me, hey, no Pokemon matches this query that you were given. All right, so now it's starting to look more like a RESTful API. All right. Let's make sure everything still works. I run a GET request. Here we can see that Pokemon still works for Pikachu. And if I try to send a PUT request, this should still raise an error. There you go, where we get level and captured as invalid because level was currently 20. We could change it to 20. And we can see that captured is invalid. And we could change this to true. And now we can send our request and everything would go through perfectly fine. All right. Does anyone have any questions over how we refactored this code to utilize the get object or 404 method and then insert it into our different HTTP methods of get and put requests? Fantastic. If no one has any questions, let me go ahead and stop our recording here.